Good morning. My name is Andrew Sadamchik. I'm one of the authors of Apache Cayenne, and you may know Cayenne, but this technology we'll be talking about here is new, and there will be another Cayenne presentation right after that. So today we'll be talking about LinkRest and creating data services using this new technology. First, a little bit of history. LinkRest was a project developed in collaboration between Object Style and the National Hockey League, and we solved, a big class of problems that they had, and this class of problems is generic enough so that, we're sharing it with everybody. And NHL was nice enough to open source this framework, and we're developing it as an open source project on GitHub right now. And it is released with a BSD license, meaning it is not viral. You can include it in your code, in your commercial code. And the framework is under active development. It was open sourced maybe a little less than a year ago, and we already had like 17 releases since then. So what problem is it trying to solve then? The motivation for LinkRest is to provide an easy JSON HTTP interface to your existing or your data stores, whatever those are. And by default, this data store is a relational database, but it can be a NoSQL database, it can be an LDAP server, or like really anything. As you've seen yesterday, and Aaron started this topic about web development going from server-side generated HTML and it's a server sending the presentation code to the browser, to actually the browser and client-side applications taking care of the presentation. So the server role in this is just to serve data. So it's no longer HTML. It's some kind of data structure, and the same thing happened in well, not the same, but it's sort of going in the same direction with application-to-application communication. If you go even like 5-7 years ago, the main web services technology was SOAP. And you would use XML within SOAP XML. You would put your own XML, and that's how web services operated. And right now, no matter what the client is, it can be a human sitting behind the browser, a human with a mobile phone or a tablet, or another server application. The protocol is probably the same. And this protocol, well, of course, the protocol is HTTP, but the format is JSON, and what you're sending is data. It's no longer markup. And this is where things are going. So having a good framework, having a good technology to address this type of data interaction is important. And this is why we started this project. So LinkRest is two things. And it's a protocol and it's a framework. And the protocol part is what concerns the client. So in your group, if you have front-end developers and back-end developers, the front-end developers will probably look at the protocol, how to call the service. And back-end developers will look at the framework to write the actual codes that serves the data. And if you're doing both, of course, you need to understand both. So we'll start, before we start talking about protocol and the framework, I'm showing this little data model. This is some kind of simplified content management system that has multiple domains. So each domain is a website that you serve on your CMS, right? And each domain can have multiple articles, so it's a one-to-many relationship. This is a very simple model, and I will use it in examples. So just domain and articles. So let's start with the protocol. First of all, we're talking about REST here, so it's HTTP. So there's nothing really special about it. We don't reinvent. We don't like SOAP. We don't build a layer on top of HTTP. We use it and embrace HTTP protocol. So you will see all the normal methods: get, put, post, delete. You will see the normal response code. So if a response returns 200, it means it was a success. If it returns a 404, it means the object was not found, and so on. So essentially, our protocol is it's focusing on a JSON format really, and request control parameters that you can pass in query string. Even the URL structure, we leave it up to the server developer, to the service developer. You can put, for instance, your IDs like in different parts of the URL. I follow certain conventions in my own examples, in my own applications, but you don't have to. I guess this may change in the future, this last point, because we are sort of developing the metadata services, so the framework becomes bigger, so we may need to standardize some other things, but right now it's really up to you. The first thing is document format, and I'm starting with a response document, so the documents that you receive from the server. And simple response, it's really boring. There's nothing there. There's no data. Moreover, what is there is kind of redundant because the success key, you already have a response code from your response. So if it's a 200, success is true, and if it's not, if it's in the 400 or 500 range, it's a failure. But some clients find it useful to actually look it up in JSON, so we sort of keep it there. An interesting document is a collection document. This is the main format that is served by LinkRest in responses, and it also has a success scene. It also has data, and that's where your data objects go. And here I'm showing the domain objects from our little model, and as you see, it includes ID, and it includes properties. And here it's very simple, but really it can also include relationships. So each one of these objects, it's really a tree, and it can be an infinite tree because you can go from one relationship to another, to another, to another. So essentially it can be very long if you need it to be, and very deep. And then in the bottom there is a total key, and you may think it's also redundant, but because you have two objects in this list structure, and you have a total of 2. But in reality, it's not. It's useful, and I will show you why in a few moments. So we have essential success, data, and total as the 3 keys, and everything else is your payload. So there's very little, extra information in these documents. It's all your objects. Now let's look at request objects. And request is how you put objects in request to update your entities. This is very simple. It's even simpler than the previous one. You can either send a single object or you can send a list of objects. And if you send it to the right endpoint with the right method, LinkRest will do an appropriate operation, an appropriate update. Okay, so control parameters. This is the most interesting part of the protocol. If you think of it, so the resources in LinkRest, they're not action-based, so they're real, true REST resources. The resources are URL that corresponds to an entity. So resources are URL that corresponds to a domain, for instance, or an article, and it means all domains in the database. So this URL can serve like any single domain out of your database. But on the client, you don't want everything. You just want some of this data, and the control parameters, they allow you to actually shape your response and get the data that you want, and it gives the client lots of power. So the first thing you can do is to filter. So you can only include certain objects in your response, and this is done with a key called cayenne-exp, and this is actually the only place in the protocol that mentions cayenne. And the reason for that, first of all, because LinkRest is not cayenne specific, even though it has cayenne backend as a default. The reason for that is that we're using the expression language used in cayenne for this key, and you can use your own. You can invent some other expression language and use your own key and tie it to LinkRest. So this is the same expressions you use to build queries in ORM. And the first example is just you compare a property with a constant value, and in yellow I'm showing the SQL generated. It's really straightforward. The second example is an outer join. So this syntax in Cayenne where you have a plus sign, and it results in a relationship being resolved as an outer join. And so this is how you would check for domains that have no articles at all. And this is how you do it in Cayenne as well. And the third one is it shows that actually these parameters, they can take JSON structures as well. And if you're coding in JavaScript, that can be handy because that's how your JavaScript objects are organized. And it can take a list, and the first item in this list is an expression with parameters. As you see, there's a $B at the end. And then you pass a list of parameters to that. And even though that's named parameters, it's using positional binding, and I will explain how this works in Cayenne presentation because that's one of the new features. But essentially, the point here is that you can have on your client side, you can also have data structures and that build parameterized expressions and pass them to the server without the need to format them properly and manually replace parameters. Sorting. So. First thing we did was filtering, so the next logical thing to do is sorting. And we have two keys, sort and dir, and those can be either simple properties, like sort, you can pass a property to that, and dir gives a direction for that, so ascending or descending, and ascending is default. But if you have some more complex ordering structure, like you have multiple orderings, you can also use JSON structures to pass to this key. You can pass either a single sort object, or you can pass a list of sort objects, and as you see, it generates an appropriate order by when it goes through LinkRest to Cayenne to database. So when the ultimate SQL is generated for the database, it looks familiar. Pagination. So that's where the total key is important. Of course, if you have a million rows in your table, you don't want to see them all. Even though your interface doesn't have any filters, and you have this scroll on an iPad where you can go from from 0 to infinity to go through this endless list of objects. So pagination is important for the client to get these objects small chunk at a time. But at the same time, you want to know how many objects are there. So how many objects were matched before pagination was specified. So this way you can allow people to scroll or disallow the scroll if you reach the end of the list. So essentially here we return this little window into the list. We return 5 objects in this case. This is in the last example, if you look at that. But the total on all of these examples is 10 because that's the size of the list on the server side, on the server end. So that's pagination. It's very important if you want to build any kind of client UI and access the server database. Now, pagination, I like to think of pagination as sort of getting a chunk of a vertical list, because most lists on the phone are vertical. So essentially, you get in a chunk in a vertical direction. Now, with include and exclude directives, you can actually shape your horizontal dimension. And what you have here is an object, and by default, if you don't specify any include or exclude, we will include its ID and its attributes. And attributes, as opposed to relationships, so we include simple attributes. Now, if you want a little less data, if you don't care about certain attributes, you specify an exclude, and we just trim this list. Now, the second example is you specify an include, and once you do that, the defaults are off. So you end up with just the attributes you explicitly included. And the last example is how you actually can, first of all, you can chain multiple includes, so you can specify multiple keys with includes, but you can also reference relationships in that. And you can reference attributes of related entities, and this can go any number of levels in depth. So here, a very typical task, you would want to show some domains, but for each domain you would want to show some articles, but just the article titles, because imagine the article also has a body, and this body can be quite huge in CMS. It can be, I don't know, hundreds of kilobytes, megabytes, something like that. So it's just a bunch of HTML. So if your task is to show domains and articles for each domain, you would specify include similar to this. And it serves domain IDs, and each one of the domains will have article titles. So you can really get the data that you need, and nothing more, nothing less. The there's more to include. You can also use a JSON structure for include, and the path has to be a relationship. It cannot be an attribute. And then you can actually filter this relationship, and you can sort it. So you can use the same keys you use on the root entity of the resource to shape the related entity. And the point here is like relationships, and we run into these problems with object relational mapping as well. When you build a query to just bring a certain number of objects, but then you prefetch in a relationship and you get like an infinite number of related objects. So you sort of optimized your root entity, but you get a bunch of unneeded objects that you need to go through, in your Java code to get rid of them because you don't need them at this point just to maintain the graph integrity. So you just fetch them just because of how framework works. So with LinkRest, you have a solution to that. You can actually filter your related objects as well. You can sort them. And you can do another thing. You can change the list to a map. So if your relationship is a two-main relationship, you can usually it's a list, but you can convert it to a map mapped on a property of that related entity. So you can use map by, and it turns the list into a map. And the purpose of this, besides of the obvious performance optimization, is to allow the client to request the data in a form that corresponds to the model of the UI. So essentially, you have some model of your widgets on screen, whether it's JavaScript or whether it's Objective-C and iOS application. You have some kind of model of the UI, and the server, you will be able to tell the server to give the data that matches this model. Really, and this helped us in real applications. This helped us to build very complex grids, scrollable in both directions, and with lots of information in each cell, and so on and so forth. So this is really flexible in a way the client needs it. So protocol is designed so that the client is the key and they can request anything. So, and we'll talk about the implications for the server. So this was a protocol. Now we move into framework, so how you build your server. And I'm using the term DSL for the type of API that we have here and we have in Cayenne, and this is DSL is a domain-specific language, right? Which is really just, I guess, another term for fluent API as far as Java is concerned. Where you can chain multiple methods, and the method names actually describe what you do, as opposed to just Java Beans style with setters and getters. So we're using this style of fluent API, and the framework mediates between LinkRest requests and some kind of backend. And by default, this backend is Cayenne. And we're actually working to make it easy to plug in other backends. It's already possible. It's just sort of not standardized. But we are improving that API greatly because we do have other backends, and I'm sure you will. Finally, it provides server-side controls to constrain client capabilities. And this is what I mentioned just a minute ago. The client can do too much. So on the server, you really need to control that, to restrict it. And framework gives you the tools to do that. And it's your decision how you actually do it. So before we go into building resources, REST resources with LinkRest, here is how to get started. So you declare it in Maven or whatever build technology you use. Load it in JAX-RS application, use it in JAX-RS application. And JAX-RS, for those who don't know, it's a Java technology for writing REST web services. So it's more low level. It has abstractions for things like HTTP methods, URL parameters, and so on and so forth. So essentially, it's something that helps us to build higher level abstractions, and LinkRest is that higher level abstraction based on JAX-RS. So the first thing is declare it in Maven. Nothing interesting. So just a jar with a few dependencies that, of course, Maven will get for you. But it's really very few dependencies. I think it's just Joda and Cayenne at this point, and JAX-RS. Load in JAX-RS application. Like most of this is JAX-RS boilerplate, and not even JAX-RS is Jersey, because Jersey is one of the implementations of JAX-RS, so that's what I'm using here. So the resource config is coming from Jersey. So LinkRest specific thing is in the middle. It's a LinkRest builder build, and you pass Cayenne runtime to that. So it needs to have a backend. By itself, it's a framework that deals with REST aspect of that. So you bind the backend, you get runtime, and you put it in JAX-RS container. It's available to you. So now using JAX-RS resources. So that's an example of a simple domain resource that only allows you to read domains. It doesn't allow you to update, and we'll show updates as well. And as you see, it's a one-liner. This Fluent API that starts with LinkRest .select, because we'll be selecting information, and we give it a type, we give it a config, and config gives this object access to LinkRest runtime. Then we pass it to URI info, which has all the request parameters that we just discussed, Cayenne exp, sort, and so on. And then you call select. And you get something called data response object, and then LinkRest knows how to serialize it to JSON. So JSON serializer is sort of outside of this loop. It's part of it is put into JAX-RS container. So now let's look how you actually write various resources, or rather various methods on a given resource. So here's the same example with get. We saw it already. The variation of that is get a single object by ID. So that's the second example, is how you get a single object by ID. So we have a special method in this LinkRest chain by ID, and we have select one method that underscores that we're selecting one object. So if there's nothing there, it will return 404, as opposed to the first example. If the list of domains is empty, it will return 200 with an empty list. So this is how you get your data. Now updating. And updating in REST, well, some people think that like post is to create new objects and put is to update. This may be a little simplistic. Both post and put can be used to create and update data, and delete even. But the difference between them is what they call idempotency in REST, and post is not idempotent, meaning that if you run the same request multiple times, every time you run it, chances are something will happen on the server. Some data will get changed. For instance, a new object will be inserted, and if you run it multiple times, it will be reinserted over and over. So with idempotent requests like put, and we'll have that as well, you can run it as many times, and the result will be the same as if you only run it once. So on an unreliable connection, when you send a request, nothing came back, the connection was terminated, you don't know what happened, you don't know whether your objects are there or not. So it's safe to rerun the put, but not post. But as I said, both can be used to create or update objects. And the first example is create. And we pass a string of data, and the string is essentially the JSON that we saw, the request JSON, which is just an object or a list of objects. And what it does, it just creates a bunch of insert queries. It passes it to backend, to Cayenne, for instance, and Cayenne creates a bunch of insert queries, and data is created, and we can even return back the created objects if there's actually a flag that either suppresses the data in post and put responses or includes. So it still returns the data response. And the second form is create or update, sometimes called upsert for update or insert. I like create or update. Upsert is kind of odd. Oops. Watch out. Okay. Sorry. Create or update will look for IDs in the data structure. And if there is an ID, it will try to fetch this object. If it's there, it will update it. If it's not, it creates a new one with this ID. So this is non-idempotent updates. Now put. And put is great for synchronization because it's idempotent. You can rerun it, and essentially it just does this, resets the state of your server-side collection or database table into what your client passed to it. So we have different methods to start these idempotent requests, and one is called idempotent create or update. So we don't have just create because there's really no point. And the second form is idempotent full sync. And for full sync, it means that it will also execute a delete if needed. So if you send a collection, LinkRest will compare this collection with what's on the server, what's in the entire resource, and it will create new objects that are not in the database, update objects that are already there, and delete objects that are not in the request. So this is great, and it's probably less useful for synchronizing the entire table because it's rarely that the client sends data of the entire table, but it's good for synchronizing relationships, for instance, and we'll have an example of that. Okay, so that was. Yep.
What does idempotent mean? That's a big word.
Yeah, it's a big word. It means that the request is safe to execute multiple times.
Okay.
So the result of one execution is equivalent to the result of multiple executions, if it's the same parameters. So yeah, it's too long to be in this method. I'd like to have something shorter so that I don't have to type it and read it, but. Other than that, it actually reflects what it does. Delete is very simple, and you can either delete all objects in a table. I don't know how many of you would like to do that. Or you can delete just one object by ID. And as you may remember, another way of deleting is to use the idempotent put with an empty collection or a collection just shrunk from the original size. So that's delete, and as you see, it returns simple response instead of data response because the object was wiped out. There's no more data to return back. Now relationship resource, and that's what I meant by how do you edit relationships? And to edit a relationship, you write a resource that has an ID of the root object, and this works the same for too many or too one relationships, really. Then you specify a relationship in the path, and the notation is up to you, really. So it probably makes sense to these articles to be the name of the relationship because it's just easier to code it this way, but it doesn't have to be. It's not mandated. And then you build a special chain, after you're doing select, the second line is too many parent. So that's how you constrain this resource to just the objects related to a given object. So this is how you edit relationships. And because this relationship is too many, I'm saying too many parent, and this relationship can be too one, and then it will be just parent. And the difference in notation is because of generics. So because the signatures won't match for if you want to do the type safe thing. So you have to have two different methods for that, and this is how you deal with relationships. And this is an example of a get, but the same thing works for post and put, and this is why you can edit full contents of relationship with put, for instance, and using idempotent full sync. So that's editing relationships. Now, a different topic, constraint resource views, and this is one of the security aspects of LinkRest. Not the only one, but that's the one, I'm talking about horizontal and vertical directions, so that's how you limit what the client can see in the horizontal direction, so what properties can be included. And this is useful when in your application, you have some notion of permissions of who can see what. And if you have this notion, then you can build this constraints object based on your permissions that come from somewhere, from your security frameworks that you use in your code. And you just take the security framework, take a list of permissions, and build a list of attributes and relationships that a client can see. And you don't know what attributes were requested because you don't look inside the URI info. You don't want in your code to anticipate any of that because a client can request anything based on your model, really. So you just tell what is the scope, that they can include. And if they include more, those extra includes will be truncated, and the warning will be printed in the logs. If they request less, that's fine, so we return what they requested. So, but this defines the order scope of the includes. And this ties into your security model that is, of course, outside of LinkRest, but it can be tied to LinkRest this way. And think of it, it is very important because, like, really, the client, if they know the model, if they can look at the relationships, they can actually request your entire database in one shot just by going to a single resource and then navigating the relationships. And if you have relationships back, they can go back and even request more objects than were in the initial entity. So it's really, it's really important that you are no longer working with action-based framework like you used to, where a click of a button results in an action method call and nothing else. So they can only execute this action in a regular web application, right? So here they are working with the resources. The requests are really not about actions; they're about synchronizing the resource state. So you need that, and other security techniques that we have on LinkRest. Extending LinkRest. All the examples that we've seen, there were one-liners, and you might be wondering, like, I write my applications and there's much more code there than that, right? So where does it go? Well, first of all, we've eliminated all the presentation code, so there's really less code just because of the nature of the framework. So we are dealing with data. We're not dealing with formatting. Well, somewhat. I mean, we're dealing with data shaping as well. But sometimes you need to do something like kick off some workflow when something happens, or send an email, or maybe write an audit record when somebody updated something. So the first place that comes to mind when extending LinkRest is Cayenne listeners, because Cayenne already has this mechanism. So if your backend is Cayenne will catch every single change, and you can write your own code that processes these changes, and that's what we do normally. Other things I'm talking about here, they're related to what LinkRest is. So essentially, if you have a LinkRest resource, you need to implement security, and we've seen some of that, but there's more, and I don't have time in this presentation to show it, and we'll probably show it in a lab, and there were a few requests already. So you can actually define some security policies per stack with annotations. So you can say that this entity will never be exposed in LinkRest either directly or via relationship, so you just disallow that. For everybody, no matter who you are. It can be specified per request, as we've seen with constraints. We can have custom encoders, and this is something that I haven't showed. The JSON encoding happens. There's still code to turn a data response object into JSON. So there's an encoder class, and there's a way to extend that to actually suppress some objects that a user is not allowed to see. Then there is a LinkRest adapter, and this is something that's an extension API to define, for instance, custom keys or like some custom processing of this request pipeline. And some people want that because maybe they don't like Cayenne expression, maybe they want their own way to pass all these parameters to LinkRest. So LinkRest, just like Cayenne, is written on top of dependency injection container, actually on top of Cayenne dependency injection container. So you can override any service there. So dependency injection is great. That defines interfaces, and you can bind implementations on your own and change the default ones. So that's what the adapter is for. And more API is coming, and this means we are working on metadata services where you can actually see what your entities are on the client, so you can build a generic interface. And there were a few requests to do that, so we are addressing that. Another thing that I mentioned is binding alternative backends and maybe writing some of the common ones, writing backends to like other data stores like MongoDB, I don't know. So we are LinkRest is really it's in active development, and lots of new things happen every day, and I expect it to happen for a number of years. Now the resources. We already have a website design, just haven't published it yet. So we're still having some discussions of where it should be and what should be on it. But it's on GitHub, and GitHub is a great platform for collaborative development. So you can fork it, you can, which I encourage everybody to do. You can submit pull requests, you can submit tasks. We have a task tracker there. I have a full lab demo, and probably we'll probably go through it if we do the lab later today or tomorrow. So it shows a fully working LinkRest application, and for now the contact is my email. But if there is interest from the community, if this, I really want this to become a community-driven project. So just like Cayenne, just like other open source initiatives that we've had, and this will be great. So if there is interest, we will set up a mailing list and for people to subscribe and discuss this. It's just that it was developed between the two companies, and now it's sort of it's going open. We're showing it to the world. So this is it for this presentation. Please stick for Cayenne 1, and I will answer questions.
Yesterday, Andres was telling me about his presentation, bringing me up to speed, and he said something that really opened my mind. I wanted to repeat it for everybody else. Before Andres talked to me, I was thinking about when I'm making a REST service, I need to make a lot of special APIs. Because when I'm writing my web objects application with WO components, I don't have to think so hard. We always want to separate our model from the UI, and sometimes we blur it. But I was thinking, if I'm going to have an app running outside of REST, then my REST API is my only way of managing data. Because there's one thing in my head, I'm thinking, anything that's on the client, like let's say somebody's typing an email address. On the client, I may try to see if that's a well-formatted email address. Do they put the @ symbol, that kind of thing. But then we always know, we've had this drilled into us, that on the server side, we have to check it again. Is that @ symbol still part of that email address, right? Because hackers and different people, they do anything they want on the client side. And I'm always thinking that way. And then I'm thinking, if I'm doing something in REST, I've got to have this great API, but Andres told me no. I said, what do you mean? He said, no. He said, you can solve these problems better if you just think of your REST. It's kind of like a bit bucket where you're saving all your data, and you have a very minimal API. You're just editing and updating. And I said, well, I still don't get it. You're not answering my question. He said, yes, I am. He said, the other piece you need to think about is you need some sort of security, which he touched on a little bit here, but didn't really give us a full, there's not enough time. But what he was saying is that with security, you can say that, well, he had articles and he had domains in this example. So he said maybe the person who's logged in, they're able to edit articles, but they're not able to edit domains. You're able to tell who's logged in through the REST service. So what you end up doing is you're handing off everything to your client, whether it's the iOS app, your JavaScript app. You're letting the client do all the validation, all in the client. Because if you're giving them the ability to edit that field, then yeah, they can edit it. Even if they're a hacker or whatever, they're allowed to edit it. And it changed the way I was thinking. Once I realized what he was talking about, it made a lot of sense to simplify what you're doing in REST, and that's why there isn't so much code there, and you're actually going to do all the validation.
Yeah, you still need to check your values, so you can still have, all your data layer validation is still there. So, and you still, even if a user is permitted to do something, they can still send you garbage. So you're still responsible for that on the server. But yes, the model is that you're not programming to actions. You're not programming. You're programming to resources. So your resource is your entity, and the same URL serves all the operations on this entity via different web methods. So that's how you. That's how you organize your code, and all that is sort of comes from this design. So you can still have a validation, but you have to do a client-side validation, of course, for user experience as well. But as a server, you just check that it's like sort of with email. Probably your example is a good one. You still need to do this check, but you do it at the ORM, at the persistence layer.
Just how would you manipulate relationships with this model? Like you have a domain and you want to delete the relationship between the domain and one of the articles, remove it, not the article but the relationship, or even to update kind of a complete object tree, like you have the structure and you want to update the entire structure. Is there such a thing?
So we're thinking, okay, so so sort of a central place where it works like an editing context where you can just dump all your changes. It goes against REST philosophy in one way. So we're still thinking about it because it's useful, definitely in many places, especially if you have a strong client-side framework that can actually keep track of those changes. That may be common, but as far as updating relationships, I skipped a few methods that actually allow you to do that. There's like relate and unrelate method, and with creator update you can add objects to relationship, and you can also, there's even somewhat of a hack where you can actually edit foreign keys for 2-1 relationships. So you can actually essentially just specify the ID of related object when you update the main object. So you update the main object with a different ID of related object. So some of the JavaScript frameworks like it, so they work with that. So there is a way to do it, and as far as this like central service that updates every single entity, like I said, it sort of goes against REST concepts. But
relationships are important.
Yeah, relationships. It's a separate issue. So those are two things, and the first one we solve. The second one we think how to solve and whether we should.
Thank you.
You said you have to give the model to the client developers. I have a little problem with this. If you have a big domain, a big model, and you will only show a small part of it, and you don't know the developers of the client side. So you can't trust them, and they can expose your whole model.
Yes, exactly. And this is LinkRest was written on the premise that you cannot trust the client. And first of all, we still don't have the metadata services where we actually expose the model. And when we will, it will also be tied to the same security framework, essentially. So when you request metadata structure, it will be filtered. Besides, it's again like another thing in LinkRest is that it's not like a single service, single URL where you go to and all the operations are automatic. The point is even though you have to write some codes and maybe that looks like boilerplate sometimes, you define which methods are available on each entity. So if you don't have a resource to access this or that entity, it will only be accessible via includes, and those should be constrained. Yeah, so all this is definitely well understood, and this is a real problem, and this is probably like 2/3 of LinkRest is to actually lock it up to just show what we need.
That is probably clear for a lot of people here, but for me, I'm not sure. Could you summarize why, in what sense, this is very superior to what we have already with JAX-RS? I mean. Beside the fact that it is open source, which is a very important point. Just a comparison of what it's not in JAX-RS and what are the strong points.
It's essentially it's a similar technology, definitely. So it solves the same problem domain. I'm not too familiar with JAX-RS, but I'm sure there's lots of overlap. I guess the architectural point is that, first of all, we have this whole focus on security. I'm not sure what JAX-RS does there. There may be something I'm just not aware. The second is that we open the framework to other backends. So it's not really like something built on top of Cayenne. It's rather something built for like any kind of data source. and Cayenne is just a useful default because it gives you relational databases.
This last question made me think of, would it be reasonable to make an analogy between the openness of this, as this is kind of like a direct web where the rules are on the back end. You can request anything. In most REST applications that I'm familiar with or have developed or whatever, define an API for how you want to interact with it. This is more like direct to web where with no rules. It starts off with that on the client side, and you implement the rules to do security and filtering and what elements you're doing. Would that be?
Well, I mean, in a way, like if you think of like specific APIs, like I don't know, Facebook API or I don't know, GitHub REST API, they already have entities defined. So yeah, so they essentially they can use LinkRest, I guess, to build their APIs. You know, this is a technology to build API on top of your data model, and yeah, I mean the interaction process is probably similar to direct actions. I'm not sure if direct actions can serve like other method types except for like get and post, but they probably can, right? I don't know. Yeah, that's just an engine to bring new entities to the clients.
Let's say that I wanted to do an update, and I was updating an email address. And by the time it comes over, and in this case, let's say it's Cayenne as a backend, but it could have been EOF, right? It could be any backend. So it goes to the backend, and our Java code says there's something wrong with this email address. So what happens then? What does the LinkRest do? How does that get reported back to your client?
It returns a 400 response, and the good thing is that we don't reinvent the wheel here. So we just take the response codes out of the table of standard response codes in HTTP, and we return the 400 response code, which is bad request, and we specify a message, you know, telling the details. And there are ways to customize it. You can actually like build some code-based, you know, you can return a code that the client can understand. So you can actually do some meta protocol on top of that.
Cool.
So thank you. Thank you.